Okay, let's go to example two. The U.S. Beef Producers Association is just one organization that conducts various studies, the results of which are often used in advertising campaigns. Assume that one study involved a quality perception test. Three grades of beef were involved: choice, standard, and economy. A random sample of people was provided pieces of choice grade beef steak and asked to rate the quality to scale on a scale of 1 to 100. A second sample of people was given a pieces of standard grade beef steak, and third sample was given pieces of economy grade beef steak with instructions to rate the beef on the 100-point scale. Based on the sample data, what conclusion should be reached concerning the average quality perception scores of the three grades of beef? This is the goal. We are going to use alpha equals 0.05. So the goal actually is to look at if we have a difference in the scores. So we would like to look at if we do have a difference in the scores of the rating the scores. Do we have difference in terms of the rating scores between different types of categories, different types of beef, or no? So this is our goal. Remember, we have three types of beef, three types of beef. So the goal is to determine whether, no way, determine, to determine whether a difference exists between the average. I'm going to talk about what average, where we're going to speak about average uh, quality rates for the three beef types. That's it. So we are looking for the difference between the average quality rates for the three beef types. You have three beef types. We are familiar with the difference. So if you would like to look at the difference in averages, that means we're thinking about doing some kind of t-test or ANOVA. Because we have three categories, then that means we're going to think about doing ANOVA, right? So let's decide first which one we're going to go for, ANOVA or t-test. We have three samples. We do have three samples. So we have, first of all, we have an independent variable. What is the independent variable? Independent variable, which is the beef type. We have three types. So this is categorical and nominal. Nominal. It's a nominal, right? Why is that? Because you have three types. Beef types. We have three types. Okay. What about the other variable, which is the quality rate? The quality rate is the response variable based on the piece that I give you. If I give you choice, you're gonna give me the rate based on that one. Response. So we're gonna the response variable or the dependent variable is the same thing, is the quality rate, right? But there is an issue here. It's not an issue, but we have to know what kind of variable is that. It is what? These are ratings. These are ratings from 1 to 100. So it's an ordinal. It's an ordinal. And this is important. Now, because we are studying whether uh, the variation of the quality rate is kind of influenced by the beef type. That means we are thinking about, and the beef types, we have three beef types, three of them, not, we have three categories, not two. and the independent variable contains three types, then we may think about ANOVA. So at the beginning, we may think about one way ANOVA. But if you go back to ANOVA assumption, one way ANOVA assumptions, we will find that one of the assumptions, the last one, says that the response variable has to be at least interval. So it has to be interval or ratio. However, in this case, we don't have interval and ratio, we have ordinal. When you have an ordinal response, that means we're going to switch to non-parametric tests. The non-parametric tests, which is in this case called Kruskal-Wallis H test. Kruskal-Wallis H test. So we want to switch to Kruskal-Wallis one-way ANOVA test. It's like the F test. Here we have the H test. And back to the average equality, because we are switching to non-parametric, we are studying the ranks. Then we are going to focus on the median equality rates, okay? Between the median equality rates. And as I said, we're going to go to Haskell. And someone's going to tell me, is it one way? And how did you know that it's a one way ANOVA? Why it's not N way, two way, and three? Because it's obvious that we have only one categorical variable, independent variable, which is one factor. It's believed that could be this one factor that has an influence on the variation of the quality rate. That's it. So we are thinking about there is one factor. There is one factor. What is the factor? Is the beef type, which has three levels: choice, standard, and economy, right? Economy. Okay. And if you notice, it's a balanced design. It's a balanced design because the samples are equal. So it's a balanced design study. It is a balanced design study. Okay. So what are the hypotheses? The hypotheses we're going to have, the first one is going to say that we have no difference in terms of the medians. So tilde, the median is, where's tilde? I don't see it. Let me check tilde. Okay. Mu choice, the median of the choice is actually equal to the median of the standard, is actually equals to the median of the economy. I'm going to change this to standard. I'm going to change this to economy. Okay. However, the alternative hypothesis, which is, alternative hypothesis says not all population medians are equal, or at least two of them are different. At least two of them are different. Before we conduct the Kruskal-Wallis H test, we have to look at the assumptions. We have to look at the assumptions, okay? The first assumption, they have a continuous distribution. We do have we may assume that it's a continuous distribution. It's not discrete distribution. The data at least ordinal. We do have an ordinal response variable now. The samples are independent. None of the respondent is affecting the probability of choice of the other one. So they're all independent samples. Also, the samples, they have almost the same distribution, but they are different in terms of the center point, which is, we may assume this one. Actually, we have very small data set. So we are not very picky in terms of the assumptions of non-parametric tests. They can be reliable and we may use them, okay? So we may assume all of these. Okay, so what we are going to do, we are going to go to parametric one-way statistics to tasks and utilities. Then we're going to scroll down to linear models, then parametric one-way. Then I'm going to double click. I'm going to choose stake. Then my dependent variable is the quality variable, is the quality rate. Then we have the beef type. I go to options. We have many non-parametric tests. I'm going to choose the first one, which is the one that we care about in this class, Kruskal-Wallis H test. If you would like to read about others, you can do so, and pros and cons for everyone, by the way. Also, we would like to look at if there is a difference between the ratings. The difference between whom? Pairwise multiple comparison analysis. I'm going to choose this one. Because the default alpha is 0.05, I'm going to keep it, then run. Okay, so we've got one, two, three, four tables. Three tables, one chart. Number one, the table, the first one gives the Wilcoxon scores, which is the ranks. The ranks. We are ranking these, by the way. These are ranked from the smallest to the max, to the largest. For example, what is the smallest value here? It's actually 62. This is gonna be rank number one. This is rank number one. This is gonna take the value one next to it. This is two. This is a three. This is four, and so on. Oh, we have two of them, so we switch. I mean, with Caxton, I guess this 4.5 and this 4.5. Then we switch to after 4, 5, 5, 6, and so on. Give them ranks until the largest, you know. So each sample, we have 6 observations. The sum of the scores, these are the sum of the ranks, the sum of the ranks. So because we have the choice has the highest number of sum of the ranks, we have 90. Standards, we have 51. Economy, have 29. That tells you that the economy given the lowest ranks, actually. The choice given the highest ranks. So these are the sums of the scores, not the scores of the ratings. No, the ranks. Okay. However, to consider that there is no difference in terms of the ranks, we are assuming that they have the same summation of the ranks because we have 6 each. So we have 18. 18. So from 1 to 18, we are expecting the choice have to have a ranks to be 57, 57, 57 to say that there is no difference, right? But in this case, we in reality, we have these sum of the scores, okay? Also, we have the mean score of the ranks. So this is the mean score of the ranks. So this is basically, if you actually divide 90 over 6, you're going to get 15. If you divide 51 over 6, you're going to get about 8.5. If you divide 29 over 6, you're going to get about 4.8, which is about 5. So these are the mean scores of the ranks, and you can see them in the chart. So the charts of the ranks. So this is the choice, the distribution of the ranks of the choice. It's skewed, right? It's skewed. Also, we have the ranks of the standard. Also, we have the ranks of the economy, which is the lowest. It takes the lowest ranks. And after that, we would like to look at what? We would like to look at the Kruskal-Wallis test, the one that we care about. This is the chi-square value, degree of freedom, then the p-value. The p-value is less than 0.05. In this case, we do have a statistical difference. We do have a significant difference, statistically significant difference between the medians. So because the p-value less than alpha, then we do have evidence to reject the null hypothesis. So we reject the null hypothesis. When you reject the null hypothesis, that means you're accepting this, the alternative hypothesis. By the way, we don't accept the null hypothesis. We either reject the null hypothesis or we fail to reject the null hypothesis. When you delete these columns. When you reject the null hypothesis, that means you have strong evidence to accept the alternative hypothesis. The alternative hypothesis says what? Not all population medians are equal. So we do have differences. We do have statistically significant difference between the medians of these types. At least two of them, not all of them. We don't know yet. We do have a statistically significant difference in the medians between at least two of these types. In the medians of, between these two, at least two of them. Which ones? Which ones are statistically different? All of them? So, do we have statistical difference between this and this, or this and that, or this and this? We look at the last table, the very last one. Okay. This one's going to tell you whether we have a statistically significant difference between choice and standard. We look at the p value. Do we do a really difference? Yes, we do, because we reject the null hypothesis 0.03, which is less than 0.05. We do have a statistically significant difference between the median of the choice and the standard. We do have a statistically significant difference between choice and economy. However, we do not have a statistically significant difference between standard and economy. These are differences that you see right now. These are just due to random rounds by chance. Okay. And actually, we do not see, big difference between that and that one. We see big differences between this and this and this and that. So we may report this, okay? So we may report this. Let me insert another row below this. Let me write the conclusion here. Okay, so what we say, a Kruskal-Wallis H one way ANOVA. Actually, we can say just test. Test was conducted to determine determine if the quality rates of beef different differed between three types of beef steak. We have the choice. How many pieces we have? We have six. We have the standard. We have also six. Finally, we have the economy. We have n equals 6, right? The results shows or indicated or showed whatever showed indicated statistically significant difference in equality rates medians between what and what? Between choice, actually between beef. First let's state the generic sentence, then we state the the pairwise comparison. The difference quality rates median between the beef types. Then we report the chi-square, degree of freedom, and the p-value. The chi-square of 2 equals 11.43, comma p-value equals 0.003. After that, because we do have a difference, we did a post hoc test. A post hoc comparison test using what? What test we have used? DSC, this method called DSCH, which is, the name DSCF, which is the name of the scholars. Using DSCF method showed that, or revealed that, the quality rate for choice, let's report the mean rank of the choice, which is 15.083. Okay. And the quality rate of choice mean was statistically or significantly different than Actually, it was higher than the economy standard mean rank equals 8.583, and the economy mean rank, actually small letter mean, oops, economy mean rank equals 4.83, was significantly higher than standard. Let me report the p-value here. Between the choice and standard, we have 0.033, and the choice and the economy, we have 0.011. However, there was not a statistically significant difference between the standard and economy, right? P value was 0.38. We may use approximately, by the way, here. Approximately, not equal. It's better to use approximately. Um, and the findings, what does this mean, by the way? The findings suggests that the choice beef perceived as a superior to the other categories. Perceived. Okay. So this is kind of a conclusion that we may write or we may add, or but this is everything about uh, Kruskal-Wallis H one-way ANOVA test.